Hello everyone, welcome to Microwave Engineering lecture series. In this lecture series, I'll cover the basic microwave engineering. Here I'll cover the major topics of microwave engineering. These are advantages of microwave engineering. So here I'm going to discuss about this frequency bands and then applications. So based on this applications, we'll decide the ranges and which band and the ranges. So here first band is of L band. L band is of 1 to 2 gigahertz. So here a famous application like a known application is like GSM application that we call as a popular application of mobile application. In mobile application we use GSM frequency of 0.8 gigahertz to 1.8 gigahertz. With this advanced technology of application is of CDMA. CDMA is of 800 megahertz and 1.9 gigahertz. The next is then S band. So S band frequency ranges is varying from 2 to 4 gigahertz. So in this also we have this popular application like we called as an ISM bands. This ISM band is of industrial, scientific, medical, we call as the application. So here we use this. So in this very popular application we can say as of Bluetooth. The Bluetooth frequency is of 2.4 gigahertz. So this all this of Wi-Fi, Li-Fi, all the different microwave applications. So based on this, which applications actually it's needed. So we use this S band. Next band is of C band. C band is 4 to 8 gigahertz. So the C band we use for this long distance communication, that is of such as satellites and radar. And next after C band, this is the fourth band, we call as an X band. X band ranges of 8 to 12 gigahertz. So similar to the C band, this X band is also we used for long distance like communication such as radar application, terrestrial, broadband and space applications. Next is of KU band and K band. So this we called as in high frequency applications. Bands we used for this satellite communication. These two bands like 12 to 18 gigahertz is KU band and K band is 18 to 27 gigahertz. So these two bands we use for this satellite astronomy communications, all those things. Next is Ka band is also of high frequency. This we can say of for long distance application like 27 to 40 gigahertz. Next is of V band. V band is of 40 to 75 gigahertz, like terrestrial, that is millimeter wave application. So after this V band, W band, M band, all this are the very high frequency, that is of millimeter wave band application. This W band is 75 to varying from 75 to 110 gigahertz. Next is millimeter band which is varying from 110 to 300 gigahertz. So based on our requirement and application, we have to pick the frequency, which are the desired frequency is needed for application, and we'll design based on this we'll design application for communication. Advantages of microwave. So microwave, it has a large bandwidth, that is, so we have already discussed about the applications of different bands. So microwave application frequency band it is from 1 gigahertz to 300 gigahertz. This 1 gigahertz to 300 gigahertz already we have seen how they have classified into different bands and for different applications. However, this microwave has a higher data rate. So this it is highly directive properties for microwave. Highly directive property of microwave is due to this microwave we can able for line of sight communicate directly. We can able to communicate like from transmitter to receiver. So here we have this line of sight communication, and then we can use for the satellite communication. And circuit size is very small at a microwave. So the circuit size of microwave is directly proportional to the wavelength. So this based on this wavelength, Based on this wavelength only we can able to decide the size of this antenna. So further I'll in upcoming I'll show this how this antenna size is vary with the wavelength. The microwave is used for long distance communication. It can penetrate through fog, rain, clouds, and etc. This microwave can signal can transmit at anything, and this signal can be transmitted to the entire monsoon. So it is an environmental independent frequencies. We can say this microwave frequency of environmental independent. So this microwave has an efficient size of antenna, that is antenna size is directly proportional to the wavelength. It is nothing that if we have the increase the size of antenna, then the wavelength will be of very less, like lambda will be. How we calculate this antenna size is based on this formula, that is lambda is equal to c by f. C is the velocity of light, 3 into 10 to the power of 8, and f is the frequency. And here as we increase the frequency, that wavelength will get reduced. So this if we go for this millimeter wave application, that antenna size will be very small, like of 10 mm. Not only just not 10 mm, it will reduce very further thing. So this based on this frequency, this wavelength will get vary. And then next is the fading and multipath fading is very less in microwave communication. And next the beam width is narrow with microwave. For reflector antenna we see the 70 d by lambda. So based on our requirement, these are the advantages. Based on this how we are going to use application, we have to classify our bands thing. And next is in next lecture series I'll discuss about this microwave transmission lines.